functions that we're working on today is reciprocal functions. And these functions are over x. We have 1 over x plus d. And d is going to either shift it up or down. That's going to be the translation. Or you can have x minus c in the denominator. And that's either going to shift left or right. Stretch, compression, and reflection. This will be a vertical stretch if the a is in the numerator. And if the value is in the denominator, it's going to be a horizontal either compression or stretch. And here it says vertical compression. If it's less than 1, it will be a stretch. If it's less than 1, if it's greater, it will be a compression. Kind of follows the same pattern as we did in our last lesson. In problem 1, we are going to graph the inverse variation, or we're going to graph 8 over x. Remember that x cannot equal 0 because it's undefined. Identify the x and the y-intercept and the asymptotes of the graph. Also, state the domain and the range of the function in integral notation. So here's the table. And what I'm going to do is I'm going to go ahead and move it up. And we're going to use our table to come up with our graph. So we're going to graph negative 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. Negative 8, 1. Negative 4, 2. 1, 2, 3, 4. 1, 2. Negative 2, 1, 2, 3, 4. Negative 1, 8. 1, 2, 3, 4, 5, 6, 7. I'm going to go to move it up. And that's x-axis, and there's your y-axis. Negative 1, 2, 3, 4, 5, 6, 7, 8. And you notice it's curves here. We're going to graph 1, 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 2, 1, 2, 3, 4. 4, 2, 1, 2, 3, 4, 2. And then 8, 1. We have 1, 2, 3, 4, 5, 6, 7, 8, 1. And there's our graph. So what we're going to have to do is we have to identify the x and the y-intercept. Okay? So here is our explanation. We did connect the points and we did make a smooth curve. X cannot be 0. In other words, x is not 0. So the numerator is never 0, so y is never 0. So there is no x-intercept and there's no y-intercept. There is an x-axis as a horizontal asymptote. So this is your horizontal asymptote. Y equals 0. In other words, it's undefined at y equals 0. And then our vertical asymptote. It's undefined at x equals 0. Knowing the asymptotes provides you the basic shape of the graph. So yes, we know the horizontal asymptote, the vertical asymptote. So what's going to be the domain? It's from negative infinity all the way close to 0, but not quite. And then it continues after 0, and so it's from 0 to positive infinity. The range is from negative infinity up to 0, and then it jumps, and then it goes from 0 to infinity. So there's our range, and there's our domain. For problem 2, we are working with transformations, and if we're going to analyze the parent function, it says for each given value of a, how do the graphs y equals 1 over x, which is the parent function, compared to y equals a over x. And I'm going to go ahead and type in 6 divided by x. So we notice that the value of 6 is larger than 1, and you want to think of the blue as like a rubber band, and tell me what's going to happen. You notice that if this is a rubber band, we're kind of stretching it out. So, and it's vertical. So this would be a vertical stretch. and it's by a factor of 6. And that's what you can see here. Now, what happens if it's less than 1? So I'm going to go to the tab, and no longer am I going to have 6. I'm going to have a decimal which is less than 1. And you notice something happens to the graph. The graph compresses. See the red? That's the new graph. So this will be a vertical compression. And it's by a factor of 0.25. Now we know when we have a negative in the past, we've talked about reflection. And you're going to see that there is going to be a reflection. So I'm going to go to the tab, and I'm going to go up to 0.25. And it's no longer 0.25. Now we know that the 6 is going to stretch it. But let's see what happens when we have a negative. We introduce a negative. So I'm going to press enter, and then we're going to see what's going to happen. You notice the graph is on this direction. They're in quadrant 2 and quadrant 4. Quadrant 2 and quadrant 4. So yes, it's a reflection, and it's also a stretch. So it's a reflection, and it's also a vertical stretch. It's a reflection over the x-axis. Over the x-axis. We're continuing with transformations of reciprocal functions. Here's a different scenario. What are the graphs of each rational function? How are these graphs different from the parent function? Give the domain and range in inequalities. So you have 1/2 x plus 2. So if I were to graph the parent function would have an asymptote on the y-axis, but the parent function would have an asymptote on the x-axis, and the parent would look something like this, right? So the red shows you where the parent function is. The blue shows you that shift going up 2 units. And it's right here. Here's the parent function. So what I'm going to do is I'm going to go to the tab section. I'm going to type in the parent function, but there's going to be a shift of 2 units up. Now you notice the red is the new function, and you notice that it still has a vertical asymptote at x equals 0. The horizontal asymptote is different. It's actually at the 2 spaces that it goes up, which is y equals 2. I'm going to press enter. And there is the horizontal asymptote. That's a horizontal asymptote. And that's the vertical asymptote. And those are where the 2 values are undefined. So it's asking what is the range, the domain and range? Well, to obtain the graph, you can shift the graph up 2 units. Notice you also shift the horizontal, which we said. The vertical doesn't change. So it says the domain will not change. So the domain is still going to be, and you can write this down, domain is x greater than 0 or x less than 0. Why? Because of the vertical asymptote, x equals 0. Now, the range is a little bit different. Since we went up 2 units, it's going to be y is greater than 2 or y is less than 2. So your domain is still x greater than 0 or x less than 0. The range is what changes. Y is greater than 2 or y is less than We're continuing transformations. Now the minus and the plus will be in the denominator. So it says, what are the graphs of each rational function? How are these graphs different from the parent function? Give the domain and range and set notation. So to obtain the graph of y equals 1 over x minus 1, you can shift to the graph 1 unit to the right. And we're going to see that. So just like our other transformations, when we have a minus 1, it's going to be in the denominator, it's going to shift to the right. Plus 2, it's going to shift to the left. So we're going to go to the graph tab, and you're going to type 1. Now you might want to do control division. 1 divided by x minus 1. And you're going to see how it shifts. You notice it shifts to the right. The horizontal asymptote doesn't change. Now the vertical asymptote changes. So the vertical was at x equals 0. Now it's at x equal 1. So what I'm going to do is I'm going to press tab. And I can't draw that. But it's at x equal 1. Notice that this will also shift the vertical asymptote 1 unit to the right. That's what I said. So what's the domain? It's all numbers except for 1. And that's what it means. It's all numbers except all values except for 1. The range of the function will not change, and its y will not be 0 because y, that's a horizontal asymptote. So y will not be 0. Example 2. We have y equals 1 over x plus 2. This is either going to go left or right. And remember, as we've done in the past with other transformations, if it's plus 2, it's going to go to the left. So I have the parent function here. The vertical asymptote is at x equals 0 because it's undefined at x equals 0. And it's also undefined at y equals 0. So we're going to go ahead and graph our our new function. So go to tab, control division. It helps you to write it accurately. So you have 1 divided by x plus 2. And then for you to know where the vertical asymptote is, you need to tell me where is it undefined. We have x plus 2. Well, what's going to make this equal to 0? Negative 2. So I'm going to press enter. And you notice it shifts left. And the vertical asymptote is at x equal negative 2. So that's why the domain is all numbers. The domain is all numbers except for x does not equal negative 2. And also y is not defined, so y does not equal 0. So this is your domain, and this is your range. Okay. Your domain is all numbers except for negative 2, because that's going to make it equal to 0. And it's all numbers except for 0 on the y values. This is example 5, and I recommend that while you're doing this video, to have a calculator. You can even use Desmo so you can see how the effects happen. Okay, so make sure that you're following along with your calculator. Analyze the effects of the graph of 1 over x for each transform function. How does the graph of the parent function change? The other example, the number was in the numerator. That affects the vertical. The number, the denominator, you just got to remember that's going to affect the horizontal. And if it's 3, then remember, just like other transformations, the effect is going to be 1/3. So it's going to be a compression, a horizontal compression. So, and it says it's compressed by horizontal by a factor of 3. So here we have, oh, because it's 1/3. So the reciprocal 1/3 is 3. So here we have the original function, and here is the new function. You notice that it horizontally does compress. So we're going to go ahead and see this here. We have control division. It's 1/3 and then we have the variable in the denominator. So the factor is by 1/3, so the reciprocal is 3. We press enter, and you notice it does compress. Multiplying x by a constant will stretch or compress the graph of the parent function horizontally. In this example, the graph is compressed by a factor of 3. Since the factor is 1/3, it's going to be 3. So the next example is y equals -1/2 2x. So here's our table, and here's our values, and here's our parent function, 1/x. What I'm going to do now is you're going to notice that that 2 is going to horizontally compress by a factor of 2. So I'm going to go to menu, graph, and we have -1/2, or I want to say 1 divided by -2x. And since that negative is in the denominator, I'm going to put control equal. So yeah, let me rewrite this because I want it to come out accurate. So control division 1/-2x. And since that negative is in the denominator, it's going to reflect over the y-axis, and you're going to see that. And that's what it did. It reflected over the y-axis. You can rewrite the function as f of x equals 1/-2x. Multiplying x by a negative constant will reflect it across the y-axis. This graph is also compressed horizontally by a factor of 2. So it's compressed horizontally by a factor of 2. This is an example I want you to think about. This graph of a function is a translation of the graph of y equals 2/x. What is an equation for the function? You notice that the vertical asymptote has moved, it looks like 2, because it's going up by 2, 2, 3 to the left, and it also has moved up 4 units up. So if it goes up, then we notice that the B and the D answers are going to be incorrect. So I'm going to type in control division 2, and we know that it's going to be x, and if it's going to go to the left, it's going to be plus 3, and then if it goes up, and we notice it goes up, the horizontal goes up 4, so it's going to be plus 4. We press enter, and I think that matches our graph. So the answer is A.